Good evening, everyone. This is Dr. Polaiah, Professor CSC Data Science, Institute of Aeronautical Engineering. I am today going to be delivered online lecture. That is the subject which we are in a continuation of learning, image processing and analysis. So, image processing and analysis is a subject which we have to concentrate for the sake of which we have wanted to practice in terms of real time examples. Okay, so we are going to see the today one of the topic from the image processing and analysis. The topic name of the topic is morphological image processing. So this morphological image processing topic is one and an important topic which is playing a vital role in every industrial process. That means we are going to see this importance with the basics onwards. Okay, so we are going to see this with the help of one of the agenda. That is, as we all of you know, the agenda for each and every lecture, which is right now we are following in terms of 4 points. Point number 1 is topic introduction. Point number 2, course outcomes mapped with the topic where it is covered of module number 3, and the topic which we had to concentrate is morphological image processing. If we understand this morphological image processing concepts, how can we prove that concept for the sake of development of certain applications? So we have to concentrate certain list of applications of image processing also. So coming to this morphological image processing topic, which we are going to be discussed right now under the module number 3, that is image segmentation and morphology. The word morphology generally represents a branch of biology that deals with the form and the structure of animals and plants. However, we use the same term in mathematical morphology to extract image components useful in representing region shape boundaries, etc. So what we want to understand from this mathematical morphology, which we are going to compare a general meaning or general representation of morphology is here. This generally a representation which we maybe understand from the we can understand in terms of the structure of animals and plants only. So that means you are going to be understand this perfect meaning only in terms of branch of biological that deals with the form of and structural of animals and plants only. But whereas this we are going to be discussed right now being we are discussing in terms of engineering point of view. That means engineering application point of view. As a data analytics engineer or data scientist, data engineer, how can we understand this in the sense in terms of mathematical morphology only? So engineering concepts we are not be generalized. He is mostly specific engineering application process we are going to be understanding. That means in terms of we are going to be express that meaning, especially in terms of mathematical representation only. So that means we simply say a morphology which is represent in terms of mathematical way, then we may say that one obviously mathematical morphology to extract image components useful in representing region, space, boundaries, etc. Okay, so coming to the such a definition, if at all we are going to be implement, if at all we are going to be understand as a concept of an image processing concepts, okay, how can we improve that topic we are going to be covered in terms of gain the knowledge regarding the concept in terms of digital imaging system. So your digital imaging system right now, you are going to be developed in the view of morphological image processing only. So such a gained knowledge which we wanted to summarize as for as for topic learning outcome, we are going to be summarize that in terms of concept. That means the concepts which we are elaborately delivered only that system development only. What is that system? Digital image processing system, digital imaging system. So that is what we want to understand from this slide. So your topic is morphological image processing. Okay. So that topic concept, how we are going to be achieve, nothing but topic learning outcome is we are going to be use that concept for the development of digital image processing, where it will be very suitable towards to play the particular real-time application. Okay, so we're going to see this morphological image processing. So far, we understand from previous slides. What we understand from previous slides? What does it mean morphological? And how that morphological concept can help us process it and towards to get the certain gain in the sense that morphology in terms of image processing we have to do concentrate. So how can we concentrate that in the sense? So we are going to be concentrate in terms of that morphology is a comprehensive set of image processing operations that process image based on shapes of the image. Okay, so that means you must have to understand morphology is a comprehensive set of image processing operations that process images based on shapes, different shapes. Okay, so you wanted to process the image shapes. For the sake of understanding the concept of morphology, we are going to use morphological operations. Okay, so morphological operations, how can you are going to be used in the sense we are going to be apply that operations in terms of morphological operations apply structuring element to an input image, creating output image of the same size. I'll repeat once again. How we are using this morphological operations towards to apply a structuring element to an input image, creating an output image of the same size. Okay, input image, creating an output image in terms of same size. So input image, how it is so same. Okay, so it is output image. We are going to be get as same size in terms of input image only. So you mean to understand that the morphological operation means in terms of structuring element only, in terms of structuring element. So this structuring element which is going to be help us to understand for the process of morphological operations. Okay, in a morphological operation, the value of the pixel in the output image is based on comparison of the corresponding pixel in the input image with its neighbors. So that is the meaning of your structuring element. Means your structuring element right now defined in terms of value of each pixel in the output of the image based on the comparison corresponding pixel in the input image with its neighbors. So that is what we have to understand here. So how it may be happen, let we'll see. Here we are going to be taken to consider the way you are delivering. You are going to be delivering that one. For example, that morphological image processing, which we want to process, where the best example is here the terminologies in morphological image processing. Okay, what are the terminologies? That means you are supposed to process morphological operations. Means you are supposed to be understand the structuring element process. Morphological operation means structuring element process. So you wanted to do that in terms of understanding such a structuring element, which we are going to be say in terms of matrix or a small size templates that is used to traverse an image, Okay. So that is called structuring element. What do you mean structuring element? It is a matrix. It is a form of matrix values or a small size template that is used to traverse an image process. Okay. So how can you process that? How can you traverse that and particular image which you are selecting from input to output in terms of the structuring element is positioned at all possible locations in the image and it is compared with the connected pixels. It can be of any shape. So what do you mean to structuring element here? So this is nothing but possible location in the image and it is compared with the connected pixels. Okay, it can be any shape. So what do you want to understand that process in all possible location in the image process means we are going to be considering that in terms of three steps of structuring element process. Number one, fit. Number two, hit. Number three, miss. So what do you mean fit? When all the pixels in the structuring element cover the pixels of the object, we call it as a fit. I'll repeat once again. When all the pixels in the structuring element cover the pixels of the objective, we can call it as a fit. So structuring element covers the pixels of the particular object. So that whenever it covers all the object, then we are going to be fit. We call it as a fit. So what do you mean hit? Hit means when at least one of the pixels in the structuring element cover the pixels of the object, we call as it hit. We call as a hit. What is the difference between fit and hit? Fit means cover the pixels of the object. But here also, at least one of the pixel in the structure element cover the pixels of the object. At least one of the pixels. So that is called a hit. Okay. So when we are going to be say miss means when no pixels in the structuring element cover the pixels of the object, we call it miss. No pixels. How we are defining miss? In terms of structuring element. So in terms of structuring element, we are going to be define that when no pixel in the structuring element cover the pixels of the object. So we call it miss. So that is what here. So we can understand from here. Okay, can understand from here. When no pixel in the structuring element cover the pixels of the object, we call it miss. Okay. So now we understood the structuring element in terms of certain terminology in morphology image processing are number one fit, number two hit, number three miss. Okay, so this structural process which we want to understand from here. Okay, so all the pixels, nothing but here fit. At least one of the pixels is hit. At least no one. So miss means when no pixel in the structure element is miss. So I hope you understood this slide in detail. We'll go to have this fit, hit, miss. How can you are going to be represent? How can you are going to be define those things by taking the representation of structuring elements in the form of characteristics. Let you say, so you are taking one universal picture image processing is here. Okay. So this one now we are going to be see. This one we are going to be see. So what is the meaning of first fit? Fit means you are going to be all the pixels in the structural element cover all the pixels of the objective. We called as fit. Okay. So how can you say this? Fit means you are going to be taken to the consideration. Okay. So in this you are going to be see the fit elements. Okay. So this all neighborhood of the pixels are covered one to another. Hit means not to be all. We collected here only 4, but whereas here at least one of the pixel. Compare with your neighbors. So that is your hit. What do you mean, miss? No, here nothing is there. Nothing. You are missing. So nothing is neighbor pixels which we want to compare. So structuring element means this is the structuring element. One element, one structuring element is this. So we understood from fit to hit and miss. So based on these differences, we are going to be understand the morphological image processing, how it may be processed in terms of representation of structuring elements process, which we are going to be considered in terms of certain terminologies. What are the structuring elements terminologies? Are number 1 fit, hit, miss. See here, we understood so far structuring element. Okay, once we understand that structural elements, then immediately we can use morphological operation for the by using this structuring element. So what are the morphological operations which we know? Okay, so what are the morphological operations we want to concentrate on? Are two. So 2 of the operations which we are going to be used, mostly widely used operations are number 1 erosion, number 2 dilution. So how you may be defined the number of morphological operations are 2, such as first one is erosion, second one is dilution. How we may be defined? Let us see, for the reason of defining such a 2 of the morphological operations which we want to define right now are simply depends on the fundamentally morphological image processing is similar to spatial filtering. As we discussed in earlier class, we understood the coordinations of the process in the image processing, which we understood as spatial filtering process. Similarly, we can understand in such a way, we can understand this morphological operation process also. So what do you mean that? That means the structuring element is moved across every pixel in the original image to give a pixel in a new image or in a new processed image. So where that processed image of the value is new pixel depends on the morphological operation for combinations. So I'll repeat once again. We understand here the structuring element is moved across every pixel in the original image to give a pixel in a new processed image. So that processed image of the new pixel depends on the morphological operation performance only. So that reason based only we may going to be use the morphological operations or in terms of number 1 erosion, number 2 dilation. So these two are very important to understand one another for the sake of morphological operation process. Let me go to understand this. You see here. That means first of all we'll see the first one, that is erosion. What do you mean erosion? So erosion shrinks the image pixels or erosion removes the pixels on object boundaries. Okay, that means how it may happen. First we traverse the structuring element over the image object to perform an erosion operation as shown in the following figure. So how can you are going to be perform that? So that means the output of the pixel values are calculating using your morphological operation with following equation. What is the equation which is here we are using is pixel output equal to 1 if Fourier inverse transformation which we are going to use here if FIT fit. So your fit operation is here. Fit operation is here going to be provide the output is 1. Otherwise your fit value is not given 1, then your what we call as your output will become 0. So fit value is important here. So that mathematical equation which we are going to use define for that we can see later on. But you are understanding towards to define such a mathematically following equation towards to understand this erosion means, so in terms of output of the pixel is 1 if it is good value. Otherwise the pixel output will become 0. So we understood already the fit, hit, miss. Okay. So based on that, we can see here erosion. Now we are going to define with the following figure. This is your figure. Okay. So representation of your structuring element in terms of your erosion. Okay. So erosion strings. What is the definition of erosion? Erosion strings the image pixel, or erosion removes the pixel and object boundaries. How it is processed? Let us see here with the help of your mathematical equation. We are going to be see here. You initiate your objective. This is your objective. Okay. So from this objective, now you are applying the erosion. Now you are going to be apply the erosion. On where we are applying this one? Output of the image. Output of the image pixel values. Where you are applying output of the image values. So you are going to apply here by taking correct fit part. Only correct fit part. So this part will be final objective part. The remaining things will be removed automatically. So that is we called as a initial objective. So we have your initial objective. There you are fitted your FIT fit. So that we are apply here, and we are going to got your final. That is process of erosion. Then you are going to see that process in a simple manner as a structuring element. So we are going to see that erosion. You want to process. What are the properties of the erosion in morphological image processing? You are going to see are with best example is here. Okay, by taking one of the figure, how you are representing A part is this. Okay, so B part is this. C is this. Here A, this is one of the original image. From this, you are removing the certain edges. Then you got this. So what is this? You are here applying the erosion. You are applying the here erosion. So you know the meaning of erosion. Okay, you are going to be final fit, finding the final fit of the image. What is that? It is the final original image. Okay, so that is the C. So shows the process of the images after erosion as 3 by 3 images and 5 by 5 structuring elements respectively. So your image is basically here. You may know you are representing that 3 by 3 and 5 by 5. So 5 rows, 5 columns. That means your pixel values are comparing in this aspect. Coming to these properties, we can extend it. Okay, so we are going to be split apart joining the objects. So here, object is you are splitting. So you can strip away extensions. So that means the properties of object we can able to see in terms of split and strip. So you see here how it is strip happen, how it may be split happen. Okay, so that is one of the main properties of the result. You see, it can be repair brakes. It can repair institutions also. Can repair this in this sense. This will get like this. You compare to this and this. Which one is your most fitted? That means your required image we converted from here to here. So there is a changes. there is a change. You see here, there is a changes. This is your repaired institutions. Okay. So coming to the such operations which we are going to be continue here, the most of morphological operations are not performed using either dilution or erosion, but instead of they are performed by both. Two most widely used compound operations are number one, closing. By first performing dilution and then erosion, you are going to be apply the second part of opening, closing, opening. What do you mean closing? By first performing dilution, then erosion. First you have to apply dilution, next erosion. But whereas opening means first by performing the erosion first, then dilution. So that means that you are going to see this. This is the your dilution and erosion of the object. That means you can understand at a time two morphological operations are here. Okay, dilution and erosion. So if you once you are going ahead with what we call closing operation process, that is compound process here. Previous one we have gone through certain examples of your erosion is single one, but here compound operations which we are applying both in terms of closing and opening. So closing means first what you have to perform erosion. Sorry, closing means you have to perform first of all dilution and then goes to erosion. But whereas opening means first you have to perform the first operation, that is erosion operation, then it goes to dilution operation. So you can see that clarity of the operations in terms of compound operation of morphological operations by using this figure. Okay, you see it is your original image. Okay, so in this first of all you have to apply dilution. So that means opening. Okay, first one is opening. That is only what I said is first one is closing. Sorry, first one is closing. Second one is opening. What do you mean closing means? Closing means performing the dilution first. Dilution first. Closing operation means dilution first. This is closing. This is closing. First we have to go to the dilution operation. Dilution means you have to apply the first perform the dilution and then goes to erosion. So that is what we are going to do here. So your original figure right now happening, how you may see here, your dilution happen, your erosion happen. Okay, so this is your closing for compound operation. Closing compound operation. But here opening operation. Let you see here. First, what you have to do? You have to apply the erosion. First, perform the erosion morphological operation. Then goes to the dilution operation. So you can see the difference between these two. How it may be happen. Your original image, it may be help you to understand the difference between closing and opening compound operation of the morphological operations. Okay. So with this, let me going to be have certain applications which we have to concentrate right now. Those are extracting your boundaries in an image process to again information, understand the features of an images. Extract and understand the features. So how can you process? It happen by using morphological image processing only. So there we can apply the edge extraction of an image object. Image means object. So you can see that in terms of characteristics. So you are going to be process in terms of pre-processing to represent the image characteristics. This process can help the researcher and to acquire the data from the image. You can perform the boundary extractions of an image by following the steps. Step number 1 is create an image. Is creating image is E. E means erosion, by erosion process. This will shrink the image slightly. The kernel size of the structuring element can be verified accordingly. Go to second step. Step number 2. Abstract the image E from the original image. By performing the first step, you can get the boundary of our object. So let you see the same example is here. you are applying the morphological image process. Let you take this is your original image. In this image, you are applying the dilution or erosion. So you are going to be fit to this. So you can apply in a easy manner. So that means your objective is here. Your objective of the image is here. You are going to be keep fit it. So then you are going to be understand. So in terms of understanding that best example of application, you are supposed to be take the summarize this complete our discussion in terms of digital image processing application only. That means we are going to see the two of the most famous approaches in morphological operations are number one dilution, number two erosion. And coming to the, we also concentrated here, that is, you see, you have gone through the two approaches which can be combined to solve the user cases, that is, use cases. So finally, we explained the application of morphological image processing, where by using morphological image operations. So I hope you understood that complete concepts. Coming to the digital imaging applications, this morphological image processing, not only in one area of application, we can also use in all the areas. That means medical image processing, quality control system, surveillance, law enforcement, and artistics effects also. So these are the list of reference which are used for the easy to define all the concepts. With this, I'm concluding my lecture, which we understood from the definition of morphological operation, and we understood that morphological operation by defining the basic definition of morphology. So then we have gone through the morphological operations, individual applications, with certain examples also. I'm really very happy for your patient listening. Really very thankful for you. If you have any doubts, we can discuss it in detail later on. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.